In this video, I'm going to go over using some sum and difference identities, and we will have at some point during this unit, we'll do a quick little formula quiz to make sure that we've got these formula memorized, because if you don't have them memorized, it makes it really tough, but we'll practice kind of doing the algebra with using these trig identities. So we're going to start with these two. All right, these two are about cosine, all right, and they use alpha and beta. But for me, I'm going to use A and B. All right, so it's up to you on whichever ones you want to use. All right, I'm not concerned if you decide to use alpha and beta or A and B. It's your choice. So if we do the first one, we have the cosine of A minus B. So I'm going to be using the formula cosine of A times the cosine of B plus the sine of angle A times the sine of angle B. So let's write that down with this problem is going to be the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. All right, so this will be equal to the cosine of this difference. All right, now hopefully you still have that table memorized from the very first unit on trig, but if you need to refer to it, that's fine as well. So you have the cosine of pi over 3, which is 1/2, times the cosine of pi over 4, which is the square root of 2 over 2. The sine of pi over 3 is going to be the square root of 3 over 2, and the sine of pi over 4 is the square root of 2 over 2. All right, so if I simplify this, I get the square root of 2 over 4 plus the square root of 6 over 4. And because they have the same denominator, I am able to put them together in the top. The square root of 2 plus the square root of 6 over 4. All right, and that is what I'm looking for the first one. Okay, let's use one of these identities, right? So up here at the top with cosine. And I don't know what the cosine of 105 degrees is, but if I split that up into a sum or a difference, I could use the formula then to figure out what the cosine of 105 degrees is. So I decided to choose the cosine of 60 degrees plus 45 degrees, right? Because 60 plus 45 is 105. So then if I use my formula, the cosine of 60 degrees plus 45 degrees is going to be the cosine of the first angle times the cosine of the second angle. Then you do the opposite sign of what's inside those parentheses, so minus the sine of the first angle times the cosine of the second. All right, cosine of 60, we know that one. Cosine of 60 degrees is 1/2 times the cosine of 45 degrees is the square root of 2 over 2, so far very similar, minus the sine of 60 degrees, that's the square root of 3 over 2, times the cosine of 45 degrees, which is the square root of 2 over 2. So now we have the same problem essentially, or same answer as the previous one, but now we have subtraction instead of addition. So the square root of 2 over 4 minus the square root of 6 over 4. So if you would like to write them as one fraction, you can do this and all over 4. So this is our answer for the second one. Okay, let's move to sine. So sine is going to feel very similar. You'll start to get the pattern right with cosine here. The way I always do it is when it's cosine, I do cosine of the first angle times the cosine of the second angle. And then the second ones are going to both be sine. But these symbols, and I'll do some highlighting here. These symbols, I always think, opposite. So if this is addition, then this is going to be subtraction, and vice versa on the next one. So with sine, it's a little bit different. You're going to do sine and cosine of both your angles first, no matter what. And the signs are actually, S-I-G-N-S. Those signs will match. And then you just have to trade the cosine and sine. So you'll notice they switch spots. The angles don't, but the trig functions do. So again, something that you'll have to find a way for your brain to memorize it. So let's do the first one. The first one says the sine of 45 degrees minus 30 degrees. So like I said, we're going to do sine of 45 degrees times the cosine was 30 degrees. Keep the same SIGN sign. Then we're going to switch the trig identities, not the angles. So the cosine of 45 degrees times the sine of 30 degrees. So that's how we do for sine. Sine of 45 degrees is the square root of 2 over 2. Cosine of 30 degrees is the square root of 3 over 2, minus the cosine of 45 degrees, which is the square root of 2 over 2, times the sine of 30 degrees, which is 1/2. All right, so we multiply this, we get the square root of 6 over 4 minus the square root of 2 over 4. So again, if you wanted to get everything to be one fraction, you could write it like this. All right, so that's it for the first one. Let's try number 2. Number 2 says the sine of 135 degrees, minus 120 degrees. That's going to be the sine of 135 times the cosine of 120 minus the cosine of 135 times the sine of 120. Now, what makes this tougher is that you really do need to know your reference angles and you need to know your all students take classes, right? If you don't know that, it's going to make this a little bit challenging. So I know 135 degrees is in the second quadrant, all right, where it says S for sine. So whatever this reference angle is, which is going to be 45 degrees, let's do the sine of 45 degrees, and it's going to be positive because it's in the second quadrant. So the square root of 2 over 2 times the reference angle for 120, which is also in the second quadrant. So I know this is going to be negative because it's not sine or cosecant. And the reference angle for 120 is 60, and the cosine of 60 degrees is 1/2. All right, let's do the cosine of 135. This will be a negative. So cosine of 45 degrees is the square root of 2 over 2. And then finally, for the sine of 60 degrees, it's going to be a positive, right? My reference angle is 60, so the sine of 60 degrees is the square root of 3 over 2. All right, so now to kind of finish this is going to be negative square root of 2 over 4. And then I'm subtracting a negative square root of 6 over 4. When you subtract a negative, that's really addition. So it's going to be the opposite. Oh, let's put that square root in the right spot. The opposite of the square root of 2 plus the square root of 6 over 4. And if you wanted to put it in as one fraction, I guess I already did that. But anyway, I skipped a step. If you go ahead and put in a one fraction, it looks like this. Okay, so that's it for cosine and sine. Let's move to tangent. All right, so tangent, you can see tangent of A plus B. You have tangent of A plus the tangent of B in the numerator, and in the denominator, it's 1 minus tangent of A times tangent of B. The way I memorize this is these signs are the same, right? So when it's addition, we've got addition there, and then this sign at the bottom is going to switch. So this is the opposite sign. But if you notice, everything else, right, between these two identities is identical. All right, so just getting the signs lined up is going to make the most sense. All right, so the tangent of 2 pi over 3 plus pi over 4 is equal to the tangent of 2 pi over 3 plus the tangent of pi over 4 all over 1 to the opposite sign minus the tangent of 2 pi over 3 times the tangent of pi over 4. All right, so let's see what that becomes. So 2 pi over 3, that's going to be in the second quadrant. So it's going to be a negative. My reference angle is going to be pi over 3. 3 pi over 3 minus 2 pi over 3 is 1 pi over 3. The tangent of pi over 3 is going to be just the square root of 3. Plus the tangent of pi over 4 is 1. All over 1 minus that tangent of 2 pi over 3, which is negative square root of 3 times tangent of pi over 4, which is 1. So here's the answer. Negative square root of 3 plus 1 over 1 minus a negative is really addition. And if you wanted to leave it like this, that's fine. But I'm not going to leave a radical in the denominator personally. So I'm going to multiply the top and bottom by what we call the conjugate, which is 1 minus the square root of 3. You'll notice that the conjugate here is going to be essentially you copy the denominator, but you change the sign. So when I multiply in the numerator, or I should say the denominator, you'll notice the middle terms will make 0. So that's 1 minus 3 times the square root of 3 times the square root of 3, which is just 1 minus 3. And in the numerator, I'll kind of distribute that whole thing out for you. The opposite of the square root of 3 times 1, which is the opposite of the square root of 3. The opposite of the square root of 3 times the opposite of the square root of 3, which is plus 3. 1 times 1, which is 1. And then 1 times the opposite of the square root of 3, which is negative square root of 3. So if I keep going, that's going to be 4 minus 2 times the square root of 3 over negative 2. Again, you could leave it here, or if you notice, these three numbers can all be divided by negative 2. Then my answer is going to be negative 2 plus the square root of 3 over 1. So that is it. And again, I don't want you to be concerned if that was confusing, because at the end of the day, right, I said this is fine for the answer, right, which is the same thing as this. Okay.